Now to the extraordinary images tonight, the scare for visitors at Yellowstone National Park, the very close call with a geyser raining down rock and debris. Here's ABC's Mola Lenghi.
Now, a powerful eruption caught on camera at Yellowstone National Park that sent debris raining down on visitors. Mola Lenghi.
Yellowstone, a place of breathtaking beauty and serene landscapes, but beneath its calm surface, a ticking time bomb of seismic chaos. What if the next earthquake or geyser eruption isn't just another natural event, but the start of something far more dangerous? Could we be on the brink of witnessing nature's fury like never before? Stay tuned as we uncover the unsettling truth hiding beneath America's most iconic national park.
Shit! Run, run, run! Run! Run!
The geysers. Nature's pressure cookers. As we delve deeper into the captivating world of Yellowstone, it's essential to understand the very forces that drive its breathtaking geysers and hot springs. The hot water that flows through these geothermal wonders does more than simply create mesmerizing displays. It also acts as a mineral collector, picking up silica along its journey. Over time, these minerals can accumulate, causing a gradual clogging of the geyser's vents, much like how gunk builds up in a kitchen drain. Imagine the pressure building within these natural systems, hidden beneath the surface, as minerals obstruct the pathways. Eventually, when the pressure becomes too intense, the result can be explosive. An example of this is the infamous explosion at Porkchop Geyser, which serves as a stark reminder of the volatile nature of these geothermal features. But what if this phenomenon isn't just limited to a single geyser? What if Yellowstone's geysers are all ticking time bombs, silently gathering pressure until the moment they release it all at once? The very thing that draws millions of visitors each year, the park's thermal beauty, could be the very thing that forces an evacuation of unprecedented proportions. The thought alone is terrifying. A chain reaction of geyser eruptions, each one triggered by the next, as though Yellowstone itself is reaching its boiling point. These geysers are nature's pressure cookers, where heat and force are constantly on the rise, often with little to no warning. One of the most chilling facts about Yellowstone's geothermal system is its unpredictability. Experts monitor, they analyze, but at the end of the day, it's nature that holds the power, and she doesn't always play by the rules. Take the Old Faithful Geyser, for instance, renowned for its predictable eruptions. But even Old Faithful has shown signs of irregularity in recent years, as if the geological forces below are becoming more erratic. What would happen if Yellowstone's most famous geyser were to erupt unexpectedly? Not just with its usual display of water and steam, but with the force of centuries of pent-up pressure. And it's not just the geysers we have to worry about. The entire park sits atop one of the largest volcanic systems on Earth, a supervolcano capable of catastrophic eruptions. While scientists assure us that an eruption is not imminent, the park's geysers are a sobering reminder of the volatility lurking beneath our feet. With each hiss of steam and burst of water, Yellowstone's geysers may be signaling something more ominous. Could these natural marvels be precursors to something far more dangerous? Something that could force the evacuation of thousands, if not millions? The thermal features of Yellowstone are not just a spectacle. They are the surface manifestations of a much larger, much more powerful system hidden beneath. And as those mineral deposits continue to accumulate, blocking vents and pathways, the pressure will continue to rise. What happens when nature's pressure cooker can no longer contain the force? How long can Yellowstone keep this ticking clock at bay? The real threat: earthquakes. But geysers are not the only concern in Yellowstone. The park is also plagued by another natural menace: earthquakes. The Yellowstone Volcano Observatory, YVO, reports that the region experiences between 1,500 to 2,500 earthquakes each year. This range isn't static, it's a wild ride, fluctuating dramatically from year to year. For instance, 2017 saw an astonishing 3,427 earthquakes, while only 78 were recorded in 2011. So, what drives this seismic activity? Earthquakes are born from stress that builds up due to the relentless movement of the tectonic plates beneath Yellowstone. The park rests on a hotspot where the Earth's crust is under immense pressure from magma and hydrothermal fluids. As this pressure escalates, the rocks along fault lines eventually give way, releasing pent-up energy in the form of seismic waves that ripple outward, causing the ground to tremble. Now, think about this. Yellowstone's ground is always shifting, always moving, always on edge. These tremors aren't always felt by visitors, but they're happening all the time, quietly shaping the landscape. What's even more alarming is how unpredictable these quakes can be. One moment, everything is calm, serene even, and the next moment, the ground could be shaking beneath your feet. And it's not just a mild jolt. Some of these earthquakes could be powerful enough to do serious damage. In fact, many of Yellowstone's earthquakes occur in swarms, clusters of seismic activity that can strike without warning. These swarms have been known to last for days or even weeks, leaving the region in a constant state of uncertainty. While most of these quakes are small, the swarming behavior raises unsettling questions. What if one of these swarms is a precursor to something bigger? Something that could shake the entire region to its core? The potential danger doesn't stop at the trembling ground. When these earthquakes happen near hydrothermal features like geysers, they can trigger sudden and unexpected eruptions. Imagine walking through a seemingly peaceful area of the park when, out of nowhere, the earth begins to shake, and the nearby geysers violently erupt. The delicate balance of Yellowstone's geothermal system is already under immense pressure. What happens when that pressure is aggravated by seismic activity? And it gets worse. These earthquakes aren't just random events. They're part of a much larger geological puzzle. The movement beneath Yellowstone isn't just reshaping the landscape on a superficial level. It's shifting the very structure of the supervolcano itself. With each tremor, with each shift in the earth, magma is being redistributed, potentially bringing it closer to the surface. What if these seemingly minor earthquakes are the early warning signs of a much larger, more catastrophic event brewing beneath the surface? The unpredictable nature of Yellowstone's seismic activity is what makes it so terrifying. In other parts of the world, scientists can often forecast when and where an earthquake might strike. But in Yellowstone, the rules are different. The area is so geologically unique, so volatile, that predicting the next big quake is nearly impossible. And with thousands of earthquakes happening each year, it's like sitting on a powder keg, waiting for the next jolt that could set everything in motion. Imagine the chaos if a major earthquake struck Yellowstone today. Not only would visitors be at immediate risk, but the tremor could trigger a cascade of events that might force a mass evacuation. Roads could crack, geysers could erupt unexpectedly, and landslides could block key escape routes, trapping people in the park. Emergency services would be overwhelmed, struggling to respond to the sudden destruction. And while many of these earthquakes are small and go unnoticed, it only takes one significant tremor to shift the balance. One quake to set off a chain reaction that could change Yellowstone forever. The ground beneath Yellowstone is always moving, always threatening, and when it finally reaches its breaking point, the consequences could be far more devastating than anyone could imagine. Nature's seismic symphony. Interestingly, the seismic activity in Yellowstone serves a vital purpose in maintaining the park's unique hydrothermal systems. Think of these earthquakes as nature's own way of unclogging its plumbing. If left undisturbed, mineral deposits could obstruct the channels that deliver hot water to the geysers and springs. However, this natural balancing act comes with a cost. While these tremors can help release pressure and keep the geysers flowing, they can also disrupt the delicate equilibrium that exists between Yellowstone's seismic and geothermal systems. It's almost as if the park itself is performing a dangerous symphony, where each quake is a note that either maintains harmony or risks chaos. And the stakes are high. When seismic activity shifts the landscape, it's not just the geysers that are affected. Entire geothermal regions can undergo transformations. The park's famous geysers and hot springs rely on precise conditions to remain stable. But earthquakes, especially significant ones, can drastically alter those conditions. It's a game of chance every time the earth rumbles beneath Yellowstone. A minor tremor may simply clear some pathways, but a larger quake? That could rewrite the landscape entirely. We've already seen examples of how this seismic symphony can play out in unsettling ways. The 1959 Hebgen Lake earthquake, with a magnitude of 7.3, was a powerful event that caused landslides, dammed rivers, and reshaped the terrain in an instant. The ripple effects of this earthquake were felt deep within Yellowstone's geothermal system, as geysers like Old Faithful began to show erratic behavior, skipping scheduled eruptions and spouting higher than normal. This isn't just a historical footnote. It's a testament to how earthquakes can transform the very features that make Yellowstone so iconic. Even smaller quakes can have profound effects. The 1983 Bora Peak earthquake, measuring 6.9, was another instance where seismic activity reverberated through Yellowstone's geothermal network, creating subtle but noticeable shifts. Changes in water temperatures, shifts in geyser eruption patterns, and new hot springs bubbling to life are all possible aftershocks of such seismic events. It's as if the ground beneath Yellowstone is constantly adjusting, recalibrating itself in response to these quakes. But this seismic symphony isn't always so predictable. Sometimes it can take years for the full effects of an earthquake to reveal themselves. Scientists have observed that Yellowstone's geothermal features can be slow to react, with changes emerging gradually over time. That means the earthquakes happening today could be setting off a chain reaction that we won't fully understand until months, even years, down the line. It's like playing a high-stakes game with nature, only in this case, the rules are unclear, and the consequences could be catastrophic. What's even more alarming is the possibility of a major earthquake triggering unforeseen effects deep within the park's underground systems. Yellowstone's hydrothermal features are fed by intricate networks of underground chambers and pathways, many of which remain a mystery. An earthquake could disrupt these channels in ways we can't predict, potentially cutting off water supplies to major geysers, or worse, flooding areas that are currently stable. Imagine a Yellowstone where Old Faithful no longer erupts, or where entire hot springs dry up or explode with newfound force. And while the seismic activity helps maintain Yellowstone's geothermal beauty, it also raises an unsettling question. How much more strain can the system take? Each quake, no matter how small, contributes to a growing instability, shifting the park's underground plumbing in unpredictable ways. The very thing that makes Yellowstone beautiful, its constant, dynamic motion, may also be what makes it so dangerous. As we continue to explore the relationship between earthquakes and Yellowstone's hydrothermal features, the line between natural wonder and natural disaster becomes ever thinner. Could the next tremor be the one that tips the balance? Could this seismic symphony, which has been playing for centuries, suddenly reach a crescendo that forces us to evacuate this national treasure? The earthquake swarms. A closer look. The seismic behavior of Yellowstone is both unique and unnerving. While single, powerful earthquakes capture our attention, it's the swarms of smaller, clustered quakes that truly raise eyebrows among scientists. Earthquake swarms aren't just random. They are clusters of seismic activity that can persist for days, weeks, or even months, each one representing the restless nature of the geological forces beneath the park. And when these swarms occur, it's like Yellowstone is sending out a warning, a hidden pulse of activity that's invisible on the surface, but profoundly unsettling beneath it. Take, for example, the Maple Creek swarm in 2017, a dramatic sequence of over 2,475 earthquakes that rumbled through the park from June to October. What started as a moderate 4.36 magnitude quake on June 16th quickly revealed itself to be the tip of an iceberg, a much larger, prolonged event that no one saw coming. It was as if Yellowstone's geological heart was beating at a frenzied pace, creating a nearly constant vibration underfoot that tourists couldn't see, but scientists were all too aware of. The swarm's intensity and duration prompted researchers to ask difficult questions. What exactly triggered it? And more chillingly, could swarms like this be precursors to something much bigger? Yet this wasn't even the most prolific swarm Yellowstone has seen. In 1985, the park was rocked by its largest recorded swarm, over 3,000 earthquakes in just 3 months. It wasn't just a few strong shakes. It was a barrage of seismic events that left scientists scrambling to understand what was happening. Each earthquake, though small, was like a tiny hammer tap, constantly reshaping and shifting Yellowstone's underground landscape. The earth beneath the park was in motion, but where it was heading was anyone's guess. This swarm set the standard for seismic spectacles in Yellowstone, a standard that subsequent swarms in 2009 and 2010 would aim to meet as they rattled areas between Old Faithful and West Yellowstone. What's particularly fascinating and frightening is how these swarms seem to echo the same patterns. As tectonic plates shift and pressure builds, hydrothermal fluids trapped beneath the surface get squeezed, almost like water being forced through a tightening valve. These fluids, heated to extreme temperatures by the magma below, are sent rushing through fractures and fault lines, creating a domino effect of mini-quakes that can go on for months. It's a delicate and unpredictable system, one where even a slight change in underground pressure can result in seismic chaos. Essentially, the park's swarms are like hidden alarms going off deep beneath the ground, a sign that things are moving, shifting, changing, with the full implications still a mystery. Despite the array of advanced monitoring technologies in place, such as seismographs and ground deformation sensors, scientists are still baffled by the swarm's unpredictability. While they can detect and record these events with increasing precision, thanks in large part to the expansion of Yellowstone's seismic network in 1995, they still can't predict when a swarm will start, how long it will last, or what exactly triggers it. In a place as geologically volatile as Yellowstone, this uncertainty leaves an unsettling question hanging in the air. Could one of these swarms eventually escalate into something catastrophic? Adding to the tension is the fact that these swarms often occur without any obvious warning signs. Unlike volcanic eruptions, which can sometimes be preceded by ground swelling, gas emissions, or changes in the park's hydrothermal features, earthquake swarms can strike suddenly and without fanfare. One day the ground is still, and the next, it's shaking with hundreds of tiny quakes. This randomness only adds to the sense of vulnerability. It's almost as if Yellowstone has a mind of its own, and its seismic swarms are a reminder that we're merely visitors in a place where the Earth itself is constantly rearranging its furniture, sometimes violently. And while each swarm eventually fizzles out, leaving behind only data for scientists to analyze, they always come with an unsettling afterthought. Will the next one be worse? Yellowstone's seismic record is filled with these swarms, and yet each one leaves more questions than answers. What if the next swarm doesn't stop after a few months? What if it's the precursor to something far more significant, something capable of reshaping the landscape of the park forever? In this high-stakes geological game, we're left to wonder, is Yellowstone simply stretching its legs with these swarms, or is it preparing for something much larger? As the park continues to tremble beneath the surface, the story of Yellowstone's seismic activity remains an unfinished chapter, a narrative filled with suspense, unanswered questions, and the ominous hum of an active Earth. Earthquake magnitudes, understanding the scale. In the mysterious and ever-changing landscape of Yellowstone, understanding the scale of its seismic events is crucial. Earthquakes in this region range from barely noticeable tremors to earth-shaking events that leave a lasting imprint on the park and its visitors. But what do these magnitudes actually mean? For starters, most of Yellowstone's quakes are minor, below 3.0 on the Richter scale, so small that they pass without fanfare. They rattle the ground beneath your feet, but often don't make a dent in the everyday life of the park. These are the kinds of quakes that only seismologists, with their sensitive instruments, detect. However, the moment a quake hits a 4.0 magnitude or higher, it's an entirely different story. These larger events can cause buildings to sway, foundations to crack, and structures to weaken. Though it's not common for Yellowstone to experience massive, ground-shattering quakes, the potential for damage grows exponentially as the magnitude increases. The Richter scale, a logarithmic scale, measures the amplitude of seismic waves. Each whole number jump on the scale represents a 10-fold increase in the strength of ground shaking and about 32 times more energy release. A quake that barely registers at a magnitude of 2.0 may seem like a gentle nudge compared to the violent upheaval of a magnitude 6.0 or higher, where entire landscapes can shift and the ground itself can split apart. One of the most devastating earthquakes in Yellowstone's history occurred on August 17, 1959, when the quiet of Madison River Canyon was shattered by a 7.3 magnitude quake. This wasn't just another tremor. It was an event so powerful that it forever changed the face of the park. That night, hundreds of campers and vacationers were jolted awake, their peaceful surroundings suddenly transformed into a scene of chaos. The earth roared to life, sending shockwaves across the region, and in the blink of an eye, the serene landscape became a nightmare. But the quake's real terror unfolded in the minutes that followed. The violent shaking caused a landslide of epic proportions, sending 80 million tons of rock crashing into the valley below. The debris blocked the Madison River, creating what is now known as Earthquake Lake. The enormous displacement of water from the river triggered a surge over the Hebgen Dam, turning a placid stretch of river into a destructive wave that tore through the canyon, sweeping away anything in its path. The disaster left 28 people dead, and dozens more stranded in what became a race for survival as rescuers struggled to reach the isolated site. The aftermath of the Madison River Canyon earthquake serves as a sobering reminder of the raw, uncontrollable forces lurking beneath Yellowstone. That quake didn't just shake the ground, it reshaped the region. The scarred landscape still bears witness to the power of that event, a permanent reminder that beneath Yellowstone's beauty lies an unpredictable beast. While quakes of this magnitude are rare, the possibility of another major event looms. Experts point out that earthquakes of magnitude 6.0 and above, while uncommon, are not outside the realm of possibility for Yellowstone. The complex interactions between the park's underlying magma, tectonic plates, and geothermal systems mean that even minor changes in pressure could have significant consequences. A slight shift in the crust could unleash forces beyond comprehension, rupturing roads, collapsing structures, and triggering landslides like the one that created Earthquake Lake. The Madison River quake was a devastating glimpse into what Yellowstone is capable of, but the region remains active. Every rumble, every shake reminds scientists that Yellowstone's volcanic and seismic systems are still very much alive. And while today's technology has made it easier to monitor seismic activity, predicting when the next major event will strike remains elusive. Could the next quake be a repeat of 1959, or something even more severe? The vast interconnected systems beneath the park are constantly shifting, and while we may think we understand the scale of Yellowstone's power, the truth is we've only scratched the surface. One thing is clear: the forces that shape Yellowstone are far from dormant, and the threat of a major quake is a reality that lingers just beneath our feet. The ongoing dance of earthquakes. For Mike Poland of the Yellowstone Volcano Observatory, the seismic events in Yellowstone are nothing less than the park showcasing its unpredictable character. These swarms of earthquakes aren't just casual disturbances. They are nature's own way of revealing its intricate and dynamic systems. With each tremor, Yellowstone demonstrates that it is a living, breathing entity, with a pulse driven by tectonic forces far beneath the surface. Earlier this year, a notable swarm beneath northern Yellowstone Lake captivated the attention of both scientists and onlookers alike. This cluster of activity included several quakes, with a few registering at a magnitude of 3.0. While these numbers may seem modest on the Richter scale, they signify something far more profound. Each of these events is a reminder that the geological clock is ticking, and the underground mechanisms are ever active, always adjusting in response to pressure and heat from the molten magma below. Just last week, 2 earthquakes measuring 3.1 emerged from this ongoing swarm, reminding us that even when the park appears calm on the surface, a seismic dance continues below. This is where the true excitement lies, within the delicate balance of nature's forces at play. Swarms in Yellowstone are not random flurries. They follow patterns and rhythms that can often be predicted but rarely fully understood. They ebb and flow, resembling the intricate ballet of natural forces converging in this geological wonderland. The geology of Yellowstone is akin to a grand tapestry, woven with threads of mystery, unpredictability, and interconnectedness. It's a reminder of how little we truly know about the hidden dynamics at play beneath our feet. Scientists continue to study these patterns, hoping to decipher the signs that may reveal deeper truths about the park's geothermal systems. What secrets lie hidden within the rock and water? Each tremor serves as a clue in an ongoing puzzle that has intrigued researchers for decades. Recent research has shown that these swarms can lead to changes in the park's geothermal features, altering the very landscapes that define Yellowstone. In some cases, the pressure changes associated with these seismic events can cause geysers to erupt more frequently, or even alter their patterns, as the natural plumbing system responds to the shifts in pressure. This creates a fascinating interplay between the seismic activity and the park's iconic geothermal features, adding another layer of complexity to the Yellowstone experience. Moreover, the continuing seismic activity raises intriguing questions about the park's volcanic systems. Each swarm is a potential precursor to more significant geological events, hinting at the restless nature of the Yellowstone caldera itself. Could these tremors be a sign of something larger brewing beneath the surface? Researchers remain vigilant, aware that the next significant event could happen at any moment. As scientists analyze data from the extensive Yellowstone seismic network, they are constantly faced with the challenge of predicting when and where the next quake might strike. The park is equipped with advanced monitoring technology that has greatly improved our understanding of seismic behavior. The predictable nature of earthquakes keeps researchers on their toes. Each discovery leads to new questions, further emphasizing the need for ongoing research and monitoring. One particular phenomenon that has caught the attention of scientists is the potential link between human activities and increased seismicity in Yellowstone. As tourism and infrastructure developments grow, experts are investigating whether these changes can influence the park's natural behaviors. While the idea of human impact on such a pristine environment may seem far-fetched, the interconnectedness of geological systems suggests that we must consider all variables. How might increased foot traffic and construction affect the delicate balance of the park's geothermal and seismic systems? Additionally, researchers are also examining the historical context of seismic activity in Yellowstone. By studying past earthquake swarms and significant events, they can better understand the long-term patterns that define the park's geological identity. Historical records show that Yellowstone has experienced numerous significant quakes over the years, and the patterns reveal a cyclical nature to the seismic activity. This historical lens provides vital insights for predicting future behavior, and it also highlights the importance of continuous monitoring in this region of unique natural phenomena. The prospect of a significant geological event looms large in the minds of both scientists and visitors. The memory of the 1959 Hebgen Lake earthquake and the destruction it wrought still echoes in the collective consciousness of those who explore Yellowstone. While many visitors come to witness the beauty of its geysers and hot springs, the underlying reality is that they are standing atop a volatile geological wonder. Each time they admire Old Faithful's eruptions, they might consider the power of the earth beneath them, a reminder that nature's grandeur comes with inherent risks. As we navigate the ongoing seismic dance, the question of preparedness becomes ever more critical. Emergency protocols and safety measures are in place, but how effective are they in the face of a significant event? What happens when the ground shakes beneath feet? Yellowstone's authorities regularly update and communicate their strategies, ensuring that both staff and visitors are informed about safety procedures in case of a major earthquake. However, despite these measures, the unpredictability of seismic events creates an undercurrent of anxiety. Visitors may find themselves pondering, could the next quake occur while they are witnessing the beauty of the park? How would they react in such a situation? This tension adds to the allure of Yellowstone, making every visit an experience that is both thrilling and precarious. As scientists continue their research, they face the constant challenge of unraveling the mysteries beneath Yellowstone. The dance of earthquakes is ongoing, a complex interplay of natural forces that defy easy explanation. What lies ahead for this geological marvel? As we peer into the depths of its seismic history, we are left to ponder the unknown. What secrets will the Earth reveal next? The rhythm of earthquakes in Yellowstone is far from over, and with each new tremor, the park invites us to witness its unending saga of transformation. Thanks for watching. If you found this video intriguing, hit the like button and share your thoughts in the comments below. Don't forget to subscribe and turn on notifications so you never miss out on the latest updates.